Page 5. Okay, what we have done is we have simplified, we have learned how to multiply two radicals together, and we've learned how to divide. Now we're going to do adding and subtracting. Okay, and this is a lot easier than the multiplying and dividing. Okay, so first of all, when you're talking about adding terms, they have to be like terms. So like terms, what you're familiar with variables, are like 2x and 3x becomes what if you add those together? 5x. If I have 3x squared plus 4x squared, that becomes 7x squared. They have to have the same base and the same exponent, and you add the coefficients in front, right? On here, like radicals have the same radicand. What is a radicand? Elliot, what's a radicand? Oscar, what's a radicand?
I don't know.
Jordan?
Is it that thing outside?
No, it is the number under the radical. Okay, number, we need to know this vocabulary. I thought we had this. Under the radical, a little bit surprised. So it's like the discriminant was the radicand. Okay, the number under the radical sign. So, Annika, would you say these are like radicals here?
Are those
It's radical 7 and 2 radical 7.
yeah.
Yes, they are. Same with 2 radical 3 and 3 radical 3 because they have the same radicand. Yes. How about radical 5 and radical 2? Are those like radicals? No, because
They're not the same.
the radicand is different. Okay, so when you're combining like radicals, you just add or subtract the number in front of it. Basically, you're using the distributive property, believe it or not. And I'm going to show you how that's done so that you understand why this works. The number in front of a radical 2, Matthew, what do you think that is?
The number outside of 2 is
What's the number in front of an x?
that is the
What's the number in front of x?
coefficient.
Yeah, what would that be? What number?
Slope.
What would that be? Tell me what number it would be. No, in front of an x is what? 1. So what do you think's in front of the radical here? A 1. So when you add these, you just add the two numbers in front and you get 4 radical 2. Now why I said it's a distributive property is because you could have written this as 1 plus 3 radical 2. If I would distribute that back through, 1 radical 2, 3 plus 3 radical 2, I'd get back to the original. So basically that's what you're doing. And that's why you're getting this answer. On here, Erica, what would you get for number 2? Negative 7, radical 5. And you can just go to the answer, but I want you to understand why that works. John, what would be number 3? Radical 10. This just stays the same. Okay? Hans, what would number 6 be? Or, no, 6, 4. I'm sorry. Radical 7. What would then be 6 radical 7 minus 5 radical 7? What would that be? If I would have 6 radical 7 minus 5 radical 7, what does that equal? Radical 7. So how does this equal radical 7? So what do you think this would be, Hans? 0 radical 7, and what's 0 times anything? 0. Your answer is 0. Okay? On here, Emma, 5 radical 7 minus 5. Are those like terms? No. They can't be simplified. Can't be combined. No, we aren't solving. Can't be combined. This is already simplified. You can't go any further than this. Okay, Jordan, what would this be?
You're not like changing.
Okay, you can't combine these either. You're done. They have to be the same radicand. So now when you look at that, if you look at 5 and 6, you would say, gee, I can't add any of these. However, can't I simplify something first? Nee, can I simplify radical 12? To what? Because this is 2 times 2 times 3, we can take out a 2, what we learned 2 days ago, and now I have the same radicand. So what would my final answer be? Nee, what would my final answer be? 5 radical 3. Excellent. Darren, on number 2, what would you do?
6 radical 5 plus 2 radical 5.
Okay, because you factor this. He took out a 2 and he got the 6 radical 5 plus 2 radical 5. And what would be my final answer?
8 radical 5.
Very good. 8 radical 5. I don't know why I did that. Okay, Adam, what would you do on this one? Yes, number 3. Okay, to what? So what would that become then? Good. And so what would my answer be? Very good. 3 minus 6 is a negative 3 radical 3. Okay, so now here we have a monomial times a binomial. In the past, when we've had something like that, a monomial times a binomial, we just distributed through, right? And we got 2x plus 6. We're using the same thing. We're just applying it to radicals. So, Erica, when I multiply radical 3 times radical 6, what would you do? Good girl. You have a 3, and what would 6 be? So what can I take out? A 3. And then what would you get? 3 radical 2. And here, if I multiply it now to this one, what would I get? Radical 3 times radical 7. This keeps going in and out. Well, how would I multiply this? What would that be? This is a 1 out here. You would just get 7 radical 3. Right? So your answer here, can I combine those two? Nope, you are done. Okay, Iris, how would you do number 2? Radical 10 plus 10 radical 5. Can I add them? Nope, you are done. Eric, how would I do number 3? I'm sorry. Okay, because this is 2 times 3 times x. So he took out a pair of 2's and a pair of x's. So you got 2x radical 3. The 3 got left in the house. And then what else? What happened to the 11? 11 radical 2x. And you can't combine those. Nanika, what would about number 4? Okay, instead of saying 25, just go 5, 5, A. And really, when you multiply a radical by itself, what happens to the radical? It's just going to be 5a, and this would be what? 3 radical 5a. Okay? Max, on this one, what would you do?
You would simplify
Good.
radical 8, that'd be 2, 2, 2.
Okay, so what can I take out?
And you take out a 2.
And you'd have radical what? And plus 9 radical 5. Pretty simple, right? Nothing really new. Okay, let's turn the page. We aren't going to do all of these, don't worry. Okay, on here. Now we go to a binomial times a binomial. You can use FOIL or you can use the box. This gets a little bit hard on this, so let's just watch this. On here, if I'm doing it or the distributive property, I'm going to take the radical 5 and I'm going to distribute it through. This is the first terms, this is the outside term. So when I multiply this, I'd have radical 5 times 3, right? When I do the outside, I have a minus 4, and under the radical, I have a 5 times 2. Any questions? Now I'm going to take the negative 2 radical 15. Michael, I'm going to take that away from you. When you multiply the negative 2 radical 15 times radical 3, you get a minus 2. And 15, on a factor, is 5 times 3 times 3. Everybody understand what I just did? I did the inside terms here. Now I'm going to do the last. Negative 2 times negative 4 is 8. Outside, I have 3 times, or the radicals, 3 times 5 times 2. Okay, first term, I can't take anything out, so it's radical 15. Second term, can't take anything out. Third term, I can take out a 3. Multiply with the negative 2, I get a negative 6 radical 5. Last term, can't take anything out, and you get radical 30. Can I combine any of these? No. You are done. Now let's look at the next one, and then I'm going to let you try some. If I take the first one, 6 times 2 is 12. I'm going to multiply this. You have minus 18 radical 3. Take the inside, distribute it through, plus 2 radical 3. And the last term, it seems like this is where kids mostly make their mistakes. This is 1 times a negative 3, which is negative 3. And what's a radical 3 times a radical 3?
3.
3. So what do I end up with? I have 12. I can combine these two to a minus 16 radical 3, and this becomes a positive, I don't know, a negative 9. I don't know why I have a negative there, or a positive. And now I can combine these two. You get 3 minus 16 radical 3. Okay, I want you guys to try number 3, and I want you to try number 4. Yeah. Okay, remember, did you do the box or foil when you
I
used?
did the foil included here.
Okay.
Last one we got 12 minus 18 radical 3 plus 2 radical 3 minus 3 radical 3. I don't know what to do after that.
This is 3 times 3.
3 times 3, so it'd be just 9.
Right, it's minus 9.
Minus 9.
So then what I did, Armand, I combined these terms, because you have a negative 18 and a positive 2, you have the same radicand. So those are like terms, right?
Yeah.
And then I can also go 12 minus 9 is 3.
I got it.
Okay?
Thank you.
Uh-huh. Okay, Hazim, what do you have on the first? When you multiplied radical 5 times 3 radical 5, what did you get?
3 radical 25.
And what is, instead of saying 25, we should just say 5 times 5.
Yeah,
It's 15. Very good. Okay?
plus 2 radical 5
Okay, so we multiply that plus 2 radical 5.
minus 33 radical 5
Multiply this. It almost looks like a wave, doesn't it? Minus 33 radical 5
minus 20.
minus 22.
So the final answer will be minus 7 plus 2 radical 5 minus 33 radical 5.
You can combine these two. They both have the same radicand. So this would be a minus 31 radical 5.
And minus 20.
So you combine those, then you combine these two, and here would be your final answer. Okay? Okay, let's look at this next one. Did anyone get this done already? Any questions on this one? If you're having a hard time with it, when I say the box, you could have gone back to this. You could have gone radical 5 minus 11, 3 radical 5 plus 2. If you like that method better, that's fine for right now. You would have had 3 radical 5, you would have had this, 5 times 5, that's 15. You would have had a minus 33 radical 5. You would have had a 2 radical 5, and you would have had a minus 22. Yes.
How'd you go from 3 radical 5 times 5 to 15?
Because you take a 5 out and multiply it with the 3. Okay, did something funny happen in number 4? What happened, Jordan? When else did that happen to us? I heard it over there. Farnham? Who said it? Matthew. Difference of squares. You had an x plus y, x minus y. Remember, the middle term fell out. This is the same thing. Here's x plus y, x minus y. So our insides and outsides canceled each other, and you found that out. Very good, Jordan. Because when you multiplied this, 4 times 4 is 16. This would be 4 radical 2. This would be minus 4 radical 2. And this times this would be minus 2. So what did you get as your final answer? 14. Because this falls out. And they're exactly the same. What they are called here are conjugates. You will hear this word a lot more. It's when you have the sum and difference of the same two terms. And when you have that, it's like difference of squares. Your outside and inside cancels. Where else do I have conjugates on this page?
Number 6.
Not number 6, Armand. Number 5. Notice this is 3 radical 2 minus radical 3 radical 5 minus radical 2, 3 radical 5 plus radical 2. Okay, now I've got to jump down to here. This is a common mistake also. Remember, you guys were so awesome when we were multiplying binomials that this did not equal x squared plus 9, right? We had to do the outside and inside, and we got x squared plus 3x plus 3x plus 9. This is also the same thing. Don't be packing up. I'm going to do number 8. This is 6 plus radical 3 times 6 plus radical 3. You don't just square the 6 and square the radical 3. Now you do the FOIL. 36, and you have 6 radical 3. Inside, you'll have 6 radical 3, and what's radical 3 plus radical 3? 3. I can combine the 36 and 3 and get 39, and I can combine these because they have the same radicand, and here is my final answer. When does the middle term cancel? It's when you have the same first term and the same last term and you have a plus and a minus. That you're going to have them all cancel, the outside and inside. When you have this, you're going to be able to expand it. Okay, homework. Almost forgot. 11.2, page 625. 1, 5, 10, 13, 16, 19, 22, 38 to 31, 72, 73, 85, 89, and then 90 and 92. Okay, and I had another page, but I'm not doing it. Okay, and quiz on Friday. On 11:1 to 11:2. Okay? Are we good? Okay, you can go. What's the best one?
This back.
Yeah.
How'd you get in the last problem you did, number 8?
Yeah.
How'd you get
Have a good day, you guys. You were great.
yeah, how did you get from, I know how you combine 36 and 339, but how did you get 12 radical 6? Isn't it
Add
12
this-
radical 3?
Oh, it should be 12 radical 3. You're
I
right.
knew there was something funky with